Hey guys, Joe Pye here, Advanced Innovations, Austin, Texas. Welcome back to my shop. Thank you to all my new subscribers. Thank you for all the comments. It keeps me motivated. And you know, whenever somebody says, how you doing? My standard answer is so far so good, because at any moment we know that a single phone call or anything falling out of the sky could change that. Well, that's exactly what happened this morning. I came out here in the shop and just wanted to cut a piece of material on Old Faithful here. I went to adjust the blade height and we got nothing. No adjustability. So naturally, if you have a machine like this or any other machine that has a hand wheel, a crank, or anything else that's supposed to do something while you're turning it, and you go to turn it and nothing happens, the most obvious thing is that the crank is no longer in contact with the shaft. So that's the very first thing you check. Figure out how the shaft fits into the crank. Look inside for set screws, grub screws, roll pins, whatever, and try that first. If that doesn't work, and in this case it didn't work, so we're gonna have to dig into the head of this machine. This is a DoAll 16-inch vertical bandsaw. Great machine, bulletproof. I'm sure this is something stupid, but it's probably an opportunity to show you what's inside here and what it takes to fix that. So stay tuned, let's take a look. Okay, well this ought to be fun. Let's find out what's going on in here. That's where I need my light. Okay, whatever problem we have, it's down inside here, and I'm going to hope that there's a cover that can be removed, which it looks like there is, this guy here. Hopefully the cover can come off before the whole gear unit has to come out, because then that would mean taking this off, and I really don't feel like doing that. So I'm just going to be looking for any type of a cross pin that could have sheared off, or any type of a set screw that could have backed out. I'm going to dig into it and we're going to see what we got. For the amount of time that it takes to remove the blade, I would say let's do that first. Get all the sharp stuff out of the way, reduce your risk of injury. Now with the blade off, I can raise the upper wheel to its uppermost extent, which is going to give me better access to my area that I want to address. Alright, we'll just leave it right there, see what happens. See if we're lucky enough not to have metric screws here. Oh yeah, there you go. Nice. I'm going to use a much smaller Allen key to clear out the goop in the heads, because I know these are screws. I'm not going to get carried away with my initial torque on these, because it's probably been a while since they've been out. And I'm also going to brush that out, so whatever is down inside any gears or any type of worm assemblies, we don't get all these chips down inside of it. I would definitely recommend not using compressed air in this environment. Very much like a NASCAR race team that changes tires. All the guns that they use to change the lug nuts are rear exhausting, because if it ever exhausted towards the front, the closed area is going to blow all that stuff right back in your face. So I would suggest not using air if you don't have to. A vacuum cleaner would probably be a good idea, which I have sitting right below the camera. but I'm not going to use it because there's grease on it, and I don't want to get grease on my vacuum cleaner. Now let's see if I can get lucky here. That would be awesome. I don't know what's behind this. I don't know if there's any springs or gears or excessive weight or anything else, so I'm keeping pressure on this cover until I get the screws out, and I know this whole assembly is not going to fall forward and knock me in the teeth. All right, well, that's pretty cool. I'm going to reposition the camera so you can see how that works. Very simple design, much like you'd find in the rear of your car. As the crank turns, we have a pair of gears here. As this one spins, this one translates, and I'm sure that there is a thread inside of this one here, so that as this one turns, the whole riser mechanism comes up. Now, knowing what I do about this particular setup, somewhere in this area here, we're going to have to find a set screw or a dowel pin or something that cracked off, and see if we can straighten that out. I'm going to move the camera back so I can get my hands in there, but try to keep you on top of it. Let's see if we can just actually pull that out. That would be awesome. And there's the culprit right there. Good deal. I'm going to hope that that's just a simple set screw and not a roll pin, because that's a whole nother animal. All right, we definitely have a set screw. Now the only danger here is that over time, who's ever adjusted this put such excessive pressure on it that the front of it is all smashed down. Now with our crank out, this gear should walk straight out of here. So I'm just going to put the light down and see if we can convince it to come out. Do this on the bench, it would be so much easier. There you go. Beautiful. Okay, we're going to adjust this little set screw on the bench and see if we can get it free. If we can't, then I'll punch it out and we'll put another one in there and see if we can film that as well. Stay tuned. Okay guys, well, we officially got lucky on that one. The screw did come out. It appears to be, I would guess it's a 1032 or a 1024. I know it's a number 10 because it's taking a 3/32 Allen key. But the tip of this screw should be more of a cone. So I would think that over the years the cone just saw enough reciprocal motion that it just finally gave up and walked away. So here's the crank assembly that came out. And DoAll was smart enough to put a detent in the shaft. If you ever put a shaft through a driving mechanism and you're going to engage it with a set screw or any other holding device, make sure you put a detent in it like this so that the set screw has a place to go, or put an undercut in your shaft. That way the screw, when it makes contact with your shaft, it won't raise the surface of your shaft, and then you can't get it out of the bushing once you decide to service it or take it apart in the future. So I'm going to slip over to the sander for a second and put a tip on this. It gets back in here, and we're going to put this thing back together. All right, we have a new tip on it. More of a conical point so that it will now sit down inside of the receiver feature on the shaft. Actually a little bit deeper, which is good. All right, now this is where I put everything back together. And I'll tell you what, if you ever have to do this, not only put the detent or the undercut in your shaft, but try to use a harder or a black type set screw when you do this. A lot of people that will use stainless Stainless is very soft and it'll smush down pretty quick, and if this ever were to strip out, you'd have a real project on your hands trying to do all this right in the machine. So stick with the black ones. Stainless when you absolutely have to for marine or chemical environments, but stainless is very soft. And I think I'm probably going to scoop more of that goo out of there and start fresh. And for all you guys with scales in your aprons or on your bench, you officially have another use for it. It is now a DoAll worm gear clean out tool. There you go. Price just went up. I'm going to try to keep this grease or chip laden junk away from these gears. There we go. Now since I'm in here, I'm going to look for the screw on this guy here. If I can turn it. Which I cannot. But once I get it back together, I'll rotate this guy around to the point where I can find the other feature. Chances are it's identical, and I'll secure that one as well. Might as well, you're here, right? All right, I'm going to reinstall the set screw back into this gear. I'm going to watch for it to almost pop through the center. Back it off just a hair. Gently wipe off the rotational surfaces. Walk this guy back in there. Position it such that you can see that. Now don't forget, on the reinstallation of this, get some type of visual reference to where the hole is versus this, and slip that in there just so. I'm going to put gentle torque on this screw, and I'm going to walk my handle around until I feel this screw fall down in that detent. And I think I got it. Beauty. Okay, let's tighten this guy up. Now I'm going to rotate this one around. I'm going to look for the screw on the bottom gear. Get your fingers in there. Oh, surprise, surprise. That's a whole different animal right there. There is nothing that would indicate that that's not a press fit or welded on somehow. Actually, all it has to do is spin. It really doesn't have to turn anything. If it's threaded on the inside, by the very nature of it turning, it's doing the work that it was designed to do. All right, let's put the cover back on. And it looks like we have some shims here that offset the cover. From the blade guide head. So I'll confirm that I have those all four, and we'll get this back on. But first I have to clean this mess out. Okay, I do have the other two bushings. They are very small, extremely small shims. Excuse me. Sometime in the near future, I'm going to show you how to make something like this on a lathe. And then I'm going to show you how to put it back in the lathe and bore it out and turn it down, which is a really good trick. So stick around for that one. Hey, one of the best adhesives you have in the shop is grease. So let's put some grease around that surface. And boy, I got extension cords and camera tripods and all kinds of stuff in my face right now. So we're just going to stick that to the grease. That worked out pretty good. And we're going to do the same thing over here. Just a little bit of grease. These are paper thin, and it's not going to take a whole lot for them to stick. All right, I am going to visually align the cover. And I'm going to go straight down with it. The last thing you want to do is slide around and knock those out of position. Then you got a real problem on your hands. So the cover is relatively clean on the inside. I'm going to line them up by eye as best I can and go straight down with the cover. And I'm not going to snug any of them down until they're all in. And I'll bounce the cover around to the point where I think it's just sitting pretty. And then we'll torque it down, see what we got. I'll have to say, I think I got lucky with this one. And now that everything's clean, I can actually see the screw that I needed to address. So for future reference, I can now come down here and work on that screw right there, which is what I just addressed. And hopefully I won't have to do it again, but now at least I know where it is. Using a camera on a project like this, if you ever forget what went where, just roll the film back and walk yourself back through it. So it's nice to film. It's a little awkward to film, but you never know when an opportunity is going to pop up to learn something, so don't be afraid. Just dig in. And with any kind of luck, you're going to see this column go up when I turn this, which it does. So that's a win. That wasn't too painful. Putting the blade guard back on, putting the blade back in, and closing the machine up, that's a no-brainer. So I'm just going to leave that one for another time. But there is a trick that I want to show you and share with you. If you've never changed a bandsaw blade on a large machine, they can be fairly aggressive, and they can be, you know, you wonder, how do you ship something like that? I want to show you how to fold it up. It's a pretty cool trick, so bear with me while I bend the camera down so you can see this. Okay, the easiest way to do this, and this can be done several different ways, is to position it with the teeth facing away from you and step into the inside. Now don't hold it from the top, and if your hands aren't like leather, then put gloves on, because this thing is like a razor blade and it will cut you if it gets away from you, so don't let that happen. Put your hand on top of it and rotate your hand away from you. As you're holding pressure on the floor, spin this and push down at the same time. There you go. Now put a couple of zippy ties or something on either side, and if you have to store this blade, it doesn't take up a whole lot of space. If you wanted to, you could even do this one more time with a single strand and get it down to about 6 inches, but that's really getting carried away. This is sufficient. It's a great way to store the blades. Now if you want to open it, opening it is a different story. It's like handling a bear trap that's intent on getting you. So if you have to open it, Just get it to the point where it wants to blow and drop it on the floor. Now make sure if you do this that the teeth on your blade on your cutting side are facing down. As you can see, this one is. This is a correctly positioned blade. But if you were to flip this blade inside out, I don't know if you can see it or not, but now the teeth are facing up. Teeth are facing out, and you would put this blade on and you would make contact with your metal, and it would last about 5 seconds because the teeth would all be rolled down. So let's roll that back over. Okay, there you go. Well, that's a very specific video. I don't know how many people are sitting around wondering, gee, what happens if my hand wheel on my DoAll saw doesn't raise the blade guide when I turn it? But I figured I'd throw that up there. Why not? It might be helpful. Anyway, stay tuned. Got a couple of real good ones coming this week, and I hope that you like them. Please comment. Your comments drive what I post and how I think about the environment that I'm in, because it's probably a little different than the environment you're in. So keep the comments coming. Give me a thumbs up, subscription if you like what you saw. Joe Pye, Advanced Innovations, Austin, Texas. I'm out.